In this video, I'm going to show you how to certify an LC to LC duplex link using the one jumper reference, the DTX cable analyzer with the Series 2 fiber modules in the back, and today I'm going to be doing multi-mode. These are the Series 2 because they have interchangeable adapters on them. That's what's going to allow me to do a one jumper reference. I've already changed the standard connector that comes with this, which is SC to LC, and I've done that on the remote unit already. In order to do a one jumper reference, we need to be using hybrid test reference codes, or TRCs. They're hybrid because at one end we have Duplex LC. That makes sense, we're testing Duplex LC today. The other end, a little bit strange, we have LC, but we also have an SC connector with this red thing on it, which is called a mandrel, and it's critical that you use a mandrel, otherwise your readings are going to be pessimistic. The way this works is we take our red SC connector and connect it to the output port on the main unit. Then, not through a bulkhead adapter, I'm going to connect it directly to the input port on the remote unit, and because this is LC now, I can do that. I have a 50-50 chance of getting this correct. Which one of these is it going to be? Well, these are fluke TRCs, and the way this works is red is hot, black is cold. Our output is hot, our input is cold. So that tells me I'm going to connect my black LC to the remote unit. I'm then going to grab my other test reference cord and do the same in the opposite direction. So, with my mandrel attached, I'm going to take my SC, connect it to the output port on the remote unit, and then take my black, which is cold, and connect it to the input port. And you hear that chirp. Now I should say at this stage is you'll notice on the table here I've got a whole bunch of cleaning and inspection equipment. I've already inspected and cleaned these test reference cords. Without the inspection equipment and without the correct cleaning equipment, this is not going to be very reliable for you. You need inspection equipment. Alright, so let's talk about setting up the DTX cable analyzer. I'm going to rotate the dial to setup, and with fiber loss highlighted, I'm going to hit the enter key. My test limit is currently set to TIA. If I wanted to change that to ISO, I would hit the enter key, F1 more, and go down to ISO where I see the 14763-3 standard. My fiber type is currently selected as OM2. Now that's an issue because I'm testing OM3 today. I need to change that to OM3. Why is that important? At the bottom of your Linkware test report, you're going to see a list of supported applications. That list is going to be dependent upon this fiber type selected here. If I'd left it as OM2, any links greater than 82 meters, 10G base SR would not show up at the bottom. So this is an important setting. I've got remote end setup. I'm in smart remote mode, so that stays. I've got bidirectional testing, and that's currently selected at no. Neither the TIA or ISO requires that. However, your customer consultant may require this, so please check with them first. Then we'll go across to tab number 2, where we see the number of adapters. This is an important setting because this is going to affect your test limit. It's set to 2 because the link I'm testing today is a simple patch panel to a patch panel. So I have a bulkhead adapter at one end and a bulkhead adapter at the other end, 2 adapters. And because I'm not setting a reference through a bulkhead adapter, then my adapter count is going to be 2. My number of splices is 0, even though I'm using mechanical connectors today. And when I say mechanical connectors, I'm talking about types such as the Unicam, which have a mechanical splice inside. That's part of the connect. You do not add an extra splice count in there for each of those connectors. My connector type is LC. That's not going to affect the outcome of the test result. That's just going to affect the help screens on the DTX cable analyzer. And then I've also got my test method. It's set to one jumper because I'm jumping from the main to the remote unit in one hop. I'm not going through a bulkhead adapter. And finally, on number 3, I've got my index of refraction. This is going to affect the length reported by the DTX cable analyzer. So it's important to go to the vendor's website, download the latest data sheet and make sure you have the correct values in here. Okay, let's set a reference. I'm going to rotate the dial to special functions, and with set reference highlighted, I'm going to hit the enter key, and it's going to draw a picture of my setup that I've just completed. So, I've allowed my sources to stabilize, and this is very important. You need to allow them to warm up. And that can take 5 minutes, it can take longer depending on how cold your units are first thing in the morning. So, hit the test key. And what it's going to do now is it's going to zero out any losses at the output connector and those test reference cords connected between the main and the remote unit. And it's going to come back with some loss values. And as a guide, if it's 50 micron, we want this better than minus 24.5 dBm. If it's 62.5 micron, we want it better than minus 20 dBm. And if it's 9 micron, we want it better than minus 8 dBm. That doesn't mean to say that our test reference cords are in good condition. We're going to be doing a check a little bit later on to make sure they're in good condition. So everything looks fine there. I'm going to hit the F2 OK key. I have the option here of putting in the length of the cords that I'm using for testing today. Again, that's not going to affect the outcome of the test result, but it will show up in your linkware report on your PC. So I'm going to press F2 OK. Now here's a very important step that many people miss. We want to make sure the sources are stabilized. So we're going to rotate the dial to auto test and hit the test key. If the sources are stabilized, my loss reading here should be 0 dB for each fiber path. So I'm going to ignore the pass in the top right hand corner there and look at the loss reading on the input fiber. That's the input port on the main unit here. And it is showing 0 and 0 dB. I don't care about limit or margin, I just want to make sure it's 0. So that tells me my source on my remote unit is now stabilized. I'm going to go down to my output fiber on the main unit here, and that's also showing 0 and 0 dB. So good, I know they're stabilized. On to the next step. Okay, so now that I set a reference, on to the next stage. We're going to remove the test reference cord from the input on the main unit, and I'm going to put a protective cap on it. I don't want to damage it. I'm also going to remove it from the input port on the remote unit. And again, I'm going to put my protective cap on there to make sure it doesn't get damaged. The next step I'm going to do is on the main unit here, at the same end where the mandrel is, I've now got this LC. That's going to get plugged into the input port on the main unit, and then I'm going to do the same on the remote unit here. So, on the remote unit now, I am presented with Duplex LC, and on the main unit, I'm also presented with LC Duplex. So this plugs into the patch panel at one end, this plugs into the patch panel at the other end, and I could go off and do a test. The problem is, we don't actually know how good these cords are. So before you do that, take an LC bulkhead adapter and connect the main and remote units together. Of course, red goes to black, and black goes to red. And again, if I've done this right, I'll hear a chirp. Then what I'm going to do is I'm going to run an auto test to see what the loss is here and I want this to be better than 0.1 dB if possible. Let's do that now. Okay, so let's run an auto test. And my input fiber, which is my fiber going to the main unit here, has a loss of 0.09 and 0.10, which is great. And my other fiber has a loss of 0.09 and 0.04. So I know my test reference cords are in excellent condition. Now, what you could do at this stage is ask the technician to save these results as TRC1 and TRC2, for example, and then you have documented evidence that your test reference cords were in good condition when you did the measurement. Now that we've verified our test reference cords, we begin starting to make the measurements. So, very important, particularly if you're on a building site, is when we disconnect our connectors in the middle of that bulkhead adapter, we cap the fibers. Because the last thing we want these to happen to them is for them to get damaged. Take this off to one end, take this off to the other end, and start testing. And that is how you set up successfully for an LC to LC duplex link testing using the one jumper reference.